a lot of the time when we go through notes, I will actually go through examples from the workbook itself. And so if you have that available, it makes it way easier to just screenshot each example to put in your notes that we're going to go through versus trying to write the whole problem down. Okay. Product rule, quotient rule, the trig rules that you kind of have to remember. There's a few that come up a lot more than others, of course, but we'll go through all those, try to jog your memory, and kind of go from there. Some of you on your summer assignment used product rule and quotient rule, where if you would have just done a couple little moves, the problem would have become a lot easier, and we'll go through that, okay? So let's first talk about product rule, okay? Go ahead and write out your formula, the general formula. So I've got two polynomials being multiplied together. We're going to take the derivative of that product. Go ahead and write your formula out for that. So your product rule, of course, is going to look something like that, right? The derivative of the first polynomial times the second polynomial plus the derivative, the first polynomial times the derivative of the second polynomial, okay? Something like that. If you put the commutative property, I don't care which way you put it. Sometimes you like to just put the derivatives first. As long as you have something that's equivalent to that, that's good enough, okay? Now, this is going to be example 1 from your book. Okay? So go ahead and differentiate that. Again, if you want a screenshot from your workbook, if you want to just write it out, that's up to you. But go ahead and work through that one. Using the product rule, okay, what is the derivative of this? Just this particular polynomial, 6x, okay? So I'd have 6x times 2x plus 3. And then what's the derivative of this? 2, okay? So using the product rule, you'd have something like that, okay? Whether you put the 2 in front or however you want to do that, right? How many had that for your first step? Okay, good. All right, so then we just have to simplify and combine like terms. Remember, you can leave numbers alone, but when we got variables, you need to really be thinking about simplifying those as far as you can, okay? So my next move would be to distribute the 6x and distribute 2. And so this gives me 12x squared plus 18x plus 6x squared minus 2. I've got like terms here. And that's what you would end up with. 18x squared plus 18x minus 4. How many had that? Okay. Now, yes, you have to simplify variables. Numbers, no. Variables, yes. Yep, because especially later on, we're going to use this for applications. So whenever you have the opportunity to combine variables together, please do that. Numbers, if it's just plain numbers, it's okay. Anything you can enter, the general rule is if you can enter into a scientific calculator, like a baby calculator is what I like to call them, then you can stop. Okay, but we can't enter variables into a scientific calculator, so I want you to go as far as you can with those. Now, that's certainly one way to do this problem, okay? Is there an easier way? What would it have been, Jackson?
Multiply out before you.
Right, so if we would have foiled this out to begin with, right, then I would have ended up with some polynomial, probably with 4 terms. And then we could have simplified there. So one of the things that we're going to talk about all year is finding the quickest, fastest, easiest way. And just because we were talking about product rule, which good, I mean, you read the room, we're talking about product rule, so we should probably use the product rule. But as you know, when you get to the AP exam, it doesn't tell you what to do. It just asks for a solution or asks you to solve it, or it's a multiple choice problem, okay? So if we multiply that out right away, and then differentiate that, isn't that easier than using the product rule? mean, I think so. I would hope you think so too. It doesn't matter in terms of the answer, you're gonna get the same thing. But when we're talking about the AP test, right, time isn't usually on our side. We wanna maximize the time that we're given. So if you can look and find things like this, you should. All right, so then of course when I differentiate that, 18x squared plus 18x minus 4, again, we get the same thing. I don't know about you, but this seems easier. There's less room for error here, isn't there? If the product rule, if you mess one little thing up, there's the opportunity to make a mistake. Questions on that? All right, let's go to the quotient rule now. I want you to write the rule out that you use. And I'm almost willing to bet it's going to be a little bit different than what I have, just because of the low D high minus high D low. I don't actually write it out that way. I write it out the way that you typically see it in a textbook. But again, it's the same thing. So again, what I would guess, if I were to guess, is that you would have had it like this. Right, because you have the low D high there. How many had it that way, the way in blue? Right, we understand that there's no difference though, right? So long as you kind of remember that there were a couple of you that on the summer assignment forgot to square the low when you went through it. The other thing that I want to make you, and maybe you add this to your notes, if you ever have a problem that looks like a product rule, and the denominator is a monomial, then you can do that monomial division and get it to a place where you're just differentiating single terms instead of having to use the quotient rule.
Oh, it's like...
Okay, so anyway, as I was saying, if that denominator is a monomial, try to divide it out when that'll just make your life easier when you go through and do this, okay? Example. I didn't give you one like that. So the denominator here is a binomial, unless you want to do long division or synthetic division. Yeah, this is a quotient rule, and so there's not going to be some aha, if you would have just done this, it'll be so much easier. No, there's not. That's not going to happen for this one. So go ahead and do that the long ways. I think I even get on to the next screen for this one. So yeah, so if it's just asking you to differentiate, which would be more like a multiple choice problem, once you get the bottom written out, you usually are not going to have to expand it. The thing you're going to want to look for, of course, is the top factorable. Is there anything that can cancel with part of the bottom? But most of the time, you won't have to expand it out. Since we're talking about the BC exam, a standalone problem that asks you to differentiate that requires a quotient rule, that is unlikely to see by itself. Is it possible to see a problem like that built into a free response? Absolutely. Okay, and then in that case, you're going to use whatever information they gave you, and then you're probably going to be plugging in because they're going to ask for the slope or a tangent line, or does it change direction, all that stuff, right? So of course that first part is usually going to be a point, but then when they ask you to apply it, that's where variables are going to most of the time go away anyway. Is there ever a time where you absolutely have to use the quotient rule? I don't think they're going to ever specifically ask that, but yes, you could make it 2 minus 3x quantity to the -1 and then just use the product rule instead of using the quotient rule. And then chain rule and that kind of thing. Every once in a while, this is better than that, but not usually. You're right. Usually it's better. It's usually easier algebraically to just use the product rule all the time. Okay. All right. But we're practicing. It's early, and since it's sort of your second crack at it, you can start deciding which one you're more comfortable with. Right? So, where am I at here? Now remember that my order on the top is you probably have the binomial switched around because you do the derivative second, which is fine. It doesn't matter. Okay, so just taking a look here. This one you want to be careful over on the right-hand side with the algebra. Okay, we have this minus, of course, because of the quotient rule. And then when we differentiate the bottom, it's a -3. So you want to be careful with the minuses in your distribution and getting your signs right on the top. The bottom's going to stay the same. I'm not going to expand that unless the top, when I'm done simplifying, can be factored such that there's either a 2 minus 3x or a 3x minus 2. Okay, if I can't get that type of factor out of the top somehow, there's just no reason to do that bottom. So usually what I will do is wait until I'm done with the top and do an analysis of it before I do expand it. And that's the only time I would contemplate expanding. And I don't mean expanding it like foiling it. I mean expanding it like thinking of it as 2x minus 3x, or 2 minus 3x times the quantity 2 minus 3x, okay? All right, are we good so far with this? All right, next screen, I'll multiply this out because obviously I've run out of room, okay? So wrote it again at the top, so that the top is just the repeat line. The bottom is FOIL, and then essentially what I did, and if you want to think about it this way, you're definitely allowed to, is I took those and sort of multiplied them together. So essentially what I did is I distributed a +3. Okay, so that's where the 6x squared minus 12x plus 9. I just took this and distributed a -3. And in this case, I folded it all the way out. I didn't skip any steps. Okay, so now I've got to combine like terms. Fortunately, we've got some cancellation, which makes the math fairly easy. Okay, so here's where I ended up. And we try to put things in descending order whenever possible. -6x squared plus 8x plus 1. It's not factorable because there are no factors of -6 that add up to 8. So I know that I'm not going to be able to factor that out, and that's where you should have ended up. Okay? And so, did I really do that? It's really, I missed it on all of them. Anybody catch what I missed? Say what?
It just says Y.
It just says Y. And on the other screen. Should be white part. Or in this case, I think it was, I just threw in a Y because I didn't want to keep typing the D over DX. Could also be those kinds of little things. They'll cost you a little bit. Probably that's a point on a free response, but then they'll ignore it after that. They have something they call, I think they call it double jeopardy. Once you mess it up the first time, if you keep using the wrong thing the rest of the way, they'll work with you. They won't keep penalizing you for it. Okay.
It's the same thing if you get an answer wrong. If you continue
Absolutely.
with the same answer.
Right, exactly. So if you do part 1, part A wrong, and you use the wrong answer for part B, and you use the wrong answer correctly, they're going to award you full credit on that second part, kind of thing. Okay? Questions on this so far? All right, here's where we have to really jog our memories a little bit. Our trig rules. Okay, and this actually box is in your workbook. But I think they have them all the answers written in. I'm not positive, so maybe don't screenshot it. Should I look real fast to make sure whether or not it's there? Maybe it's just like this. Actually, go for it. What page is it on? Let's look. Oh no. Go to your iBooks. It should be in your iBooks. Page 46. Does it look just like this? has one of them. I think it has two. Does it have two of them? Four. Oh, don't look at it. Don't look at it. I only gave you the first one. The rest of them, I want to see if we can remember.
Do you like to get a picture of them?
Yeah, you take a picture of the screen maybe is better than instead if you still haven't seen it. The thing that's nice is there's ones that come up over and over again. Obviously the ones with sine and cosine you end up using a lot. And so the other ones, if you're in a pinch, you can always derive the other ones, right? Because tangent is really what ratio? It's the same as what?
Sine over cosine.
Sine over cosine. So you could derive that one using either the product rule or quotient rule. Same with cotangent. Secant and cosecant are a little trickier, okay? But it can be done if you're in a pinch. Try to write those ones down. See, even if you're wrong, it's okay. We'll fix them. But fill out the box as best as you can to your memory. And if you're totally drawing a blank, that's okay. What is the derivative of the cosine? What is it? Negative sine. Right? You got the negative in there. Negative sine x. Okay. Anybody remember the tangent? Secant squared. Very good. How about the cotangent? Negative cosecant squared. Very good. Doesn't come up very often, I'll be honest with you. The tangent, derivative of the tangent comes up a lot more often than the derivative of the cotangent, right? And if we think about applications in calculus, we talk about tangent lines all the time. The last two are the I like to call them almost compound expressions, right? Because that's where we've got two pieces to it. What do we got? We got anything for this derivative of the secant? Anybody remember?
It's secant tangent.
Secant tangent? Anybody agree with Adam? Andrew does. The rest of you aren't sure? It is. Very good. Secant tangent. What do you think for the derivative of the cosecant?
Negative cosecant tangent.
Maybe say it again.
Negative cosecant cotangent.
There you go. Cosecant, unlikely that those come up. But it's still good to know. It's going to come up today in your homework. But beyond that, not very often. I remember last year we're like, oh, we better really study and memorize all the trig ones. And then they just kind of disappear. So, all right, let's do a couple examples. Yeah, we're going to do 2 examples. So this first one, is in your book. Secant, well, that's interesting. It should be g of theta, shouldn't it? G of theta equals secant theta times natural log of theta, which we don't usually think of natural log of an angle, but it can happen. We're going to differentiate those. I'm going to fix this one too. I think I can actually erase it though. I can. But I recover on the next screen if for whatever it's worth. All right, so the derivative of the secant is secant theta tangent theta, and then we're just multiplying by natural log theta. And then the derivative of the natural log is 1 over. Okay. You could stop here. That would be acceptable if there was a problem like this on the AP exam. This was still, when I was creating these, still the beginning of the year, and I just couldn't help myself from continuing to simplify because it's still in my brain that that's what you're supposed to do. So I took it one step further, which you absolutely do not have to do. If you got there right away, like I said, magically all my x's turned to thetas. I corrected on that screen, but not on the other one, okay? And that's as far as you're gonna be able to go.
Could you not take out a secant?
You could. So yeah, could I factor out a secant theta? Sure. Is it gonna get you anywhere? Not really. Yeah.
Like, why do you have to continue factoring? And like, why
You
do
don't.
you continue factoring the other one and not this one?
I didn't factor the other one, I combined like terms. Yeah, I simplified more. Factoring is, generally speaking, when we're trying to solve or find a zero, that kind of thing, that's when factoring comes in handy. Or we have a fraction where we want to simplify it. Other than that, you really don't need to do that. All right, let's get a little more layered problem. This is example 9, so no calculator here, okay? And not to say that you've been using a calculator. The auto calculator, find the slope of the graph. Y equals -3 tangent x, where x equals pi over 4. When it's asking for the slope, what are they really asking for?
Derivative.
Which derivative?
First.
The first derivative, okay? So just remember that when you're being asked to find the slope, they're asking you to find the first derivative. Okay, and in this case, they're asking you to find the first derivative when x equals pi over 4. So go for it. All right, so what is the first derivative of -3 tangent x? Do I need to use product rule here? No. What is the derivative of tangent x? Secant squared, okay, and then the -3 just goes along for the ride. So the first derivative is -3 secant squared x. Now, one mistake that sometimes people make is they try to plug the pi over 4 in right away, and then you're taking the derivative of a constant. Obviously, don't do that. That would be a problem, okay? From here, now I need to find what the derivative is at pi over 4. So I'm going to actually use proper notation for that. Okay. At some point, you have to indicate that you're taking the derivative at pi over 4. So I would say that this is necessary. If all of a sudden you just have a number without explaining where that number comes from, I would say you're being a little bit sloppy, okay? Now, I'm guessing not all of you did that. And as a point of reference, again, remember I used to say this when I was coaching baseball, all right? Just because you grade an AP exam does not mean you're not human, okay, and you don't make mistakes. So what you want to do, and my point that I was trying to make as a baseball coach was that I used to try to tell my players, look, the umpires are human, they're going to make mistakes, so don't put it in their hands. Don't put your fate into the hands of the umpire. The same thing I would tell you, don't put your fate into the hands of a grader. Be as explicit as you can so there's no room to question, okay? Now, fine, I don't know why you would know the secant of pi over 4 off the top of your head. Do you? No, you have to probably think about it. Because what do you know with respect to pi over 4 off the top of your head? 45 degrees. You know that, you probably know the sine and cosine of pi over 4. And if you need to think about these radian angle measures and convert them to degrees, go for it. Okay, nobody's going to stop you from doing that. I will tell you that in general, we don't use angle measures in calculus. We use radian measures, okay? So might still be something you want to work on. Now, what is the cosine of pi over 4? 1 over radical 2. Did you leave it like that? You didn't leave it like that in in pre-calc, I don't think, right? But you left it like that in calculus because you had to, you're allowed to keep, you don't have to rationalize denominators in calculus. So then what is the secant of pi over 4? Yeah, square root of 2. So all of that, all those gyrations that you have to make, and I saw on your summer work, a lot of you drew triangles where you needed to draw triangles. On a 30, 60, 90, for the life of me, I still have to see it. I've been doing this stuff for, 37, 38 years, and I still have to draw a little triangle for 30, 60, 90s, okay? So do whatever it takes to get it right, okay? In the end, what we've got is negative 3 times the square root of 2 squared, and of course those cancel out, and that just gives me negative 6, okay? And now something that I did that I generally would not say to do, especially when you're not sure, right? We talked about this a little bit. When in doubt, draw arrows versus putting equals. Especially when it comes to zeros and 0 over zeros and L'Hopital's rule. They hate that, but when we get more examples of that, we'll talk about that more, okay? Everything kind of review here today. Any questions on anything?